Hi guys and welcome back. Well, in this video we are going to implement frozen leg problem based on deep Q-learning. So what's deep Q-learning? We'll be familiar with it in a few moments later. Let's see inference. So how inference will be working? So basically we have a one gamer is going to trying to reach his gift point with avoiding the uh, poles and the parts that could be misleading, and he needs to find the best path in order to reach his target and to receive the gift. So he's trying to do it in a short amount of time and creating its optimal path, so based on dynamic programming. This is done with a gym and gymnasium frameworks. In this video, we are actually doing inference with a pre-trained model, right? So how we are going to do and how we are going to implement, you will see all these in deeper in this directory deep Q frozen leg problem. All right. So we have also another video. Let me show you here. You see here the gamer is trying to find the path to reach to a gift, but is struggling. It's really struggling, but finally it's going to reach. It takes like 10 seconds for him to be trained and to create a path, not to go to pole, but in fact to reach his goal. So sometimes it can also mislead it, something like this. So basically, it's trying to do some mistakes and learning by its mistakes. Well, in some cases it can take short amount of time, but in some cases longer. This is all depends on how you train and fine tune your reinforcement deep Q model. Alright. So basically, this is how it has been implemented. So we actually use Gymnasium and Gym library. We are going to design deep Q learning neural network. So here we are creating simple but really simple neural network with a forward propagation. So that later on we are going to create the replay memory, which is going to handle, append and randomly sample the buffer, which in fact contains 4 or 5 states get derived from training and environment. So later on we are creating one class frozen leg DQL, attaching and setting up all the hyperparameters. Please be careful and don't change and don't play drastically with this parameter, because in any case if you change or if you're going to make some modification, I don't really recommend you, or I don't guarantee best inference time. So please, without changing and doing any modification, try to run and see, and later on you can make some modification. Alright, so here what we are going to do, we have created hyperparameters and we initialize them. Then we are going to also initialize training set. So basically we are going to create here policy DQNN and target DQNN. So policy DQNN is so we have two networks that are going to collaborate with each other in a bidirectional way. Later on, we are going to apply these modifications and we are going to push our gamer to learn from environment, or in a best case to learn from environment, in a bad case to update or to randomly choose its action. All right, randomly choose its actions. So also we are going to later on we are going to optimize our model, our gamer, by applying some torque non-gradients. So we are going to use a deep Q learning optimal policy. So we are going to choose actions based on the randomly greedy policy. So we are going to assign greedy policy and calculate our loss between the action which is predicted and the current action. So like this, likewise, loss is going to be evaluated. Furthermore, when we are going to finish our inference training set, then we are going to make a test. This test function will be doing inference, right? So it will create a video, it will open the map, and it will be downloading your pre-trained model, which is saved previously, and to make inference, recording that video, and setting up all you need. Finally, we are going to state goal reach or fell into hole otherwise by making user to understand which kind of evaluation have been generated from your pre-trained or pre-trained model. Furthermore, when you want to make a train statement, you need to just run this part. But in case of you want to you finish training part and you want to make test, I please you to command this frozen leg part and only but only run the frozen leg. But be sure that your model path has been set it correctly, so all the results will be saved in videos folder, which will be created later on in a working directory. I hope you enjoy. So basically your inference should look like as in the case of before, as I already showed you. So basically your video should be like this. So we have a gamer is going to learn from model, from environment, to make an inference and to reach its goal. So actually you will be seeing also loss function and how it's going to iterate, how it's learned. You will be seeing during the iteration. This will be saved to your working directory, and the model will be called frozen leg DQLL. By the way, I'm also loading this to the Udemy section in this course section, so you can also, in case of problem or issue, you can just use this model which is already trained. Thanks for watching. See you in the